You have to change a lot of things from the technology, from the business, from the culture, from the workforce relationship perspectives in order for you to be successful. And you can't just do it in one swoop.
Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
This is an episode of the Ventures in Industrial IoT series brought to you by GE Ventures. In the series, we explore success factors and challenges in industrial IoT markets with CEOs, investors, and experts. Welcome back to the Industrial IoT Spotlight. I'm joined today by Maciej Kranz. Maciej is wearing a number of hats. He is the Vice President of Corporate Strategic Innovation Group at Cisco Systems. He's a faculty member at the Singularity University, a senior advisor to Acreto, an advisor as well to Foghorn Systems, and a member of the board of directors of both IoTeca Corp and Starflow Networks. He also recently published a book on the topic of IoT and how it's changing businesses called Building the Internet of Things, Implement New Business Models, Disrupt Competitors, Transform Your Industry. Maciej, thanks so much for taking the time to talk with us today. Before we kick off into our discussion, anything else that you want to say around your background to frame where you're coming from in the topic?
Eric, thank you so much for having me on the podcast. And quite often, I think we talk about IoT. Often, when I am sort of having this conversation, the first question I get is, "Oh, Internet of Things. It's about connected fridges and connected toasters," and then we get into all kinds of technology discussion. But the reason I wrote the book, and the reason I'm sort of on this quest of getting everybody started on the IoT journey, is that yes, IoT is sort of at the baseline about technology solutions, but it really is about transforming industries, transforming businesses, transforming roles that we play in our organization. And so it's a catalyst for a digital transformation at multiple levels. And that's why I think it's so important that every organization, whether it's small or large, regardless of the industry, gets started on the IoT journey. So that's sort of my mission in life over the last couple of years.
High level, you break it down into eight different aspects that need to be considered. Maybe that's a good starting point, and then we can dive into particulars. How would you break down the different aspects that business leaders should consider when transforming their businesses using this set of technologies?
If you haven't started an IoT journey, I would sort of have an advice in sort of three buckets. The first one is get started with a first project, and from that perspective, don't reinvent the wheel. There are thousands and tens of thousands of organizations that have already started on the IoT journey, and they usually are focusing on four different sort of sets of use cases. The first one is connected operations. The second one is remote operations. The third one is predictive analytics. The fourth one is preventive maintenance. So that's the first one: is pick one of these use cases, implement it, have a success. The second one is learn from your peers' mistakes. It's a new set of technologies, challenges. In the book, I actually have a whole chapter dedicated to common mistakes. So learn from your peers' mistakes. And the third one is sort of maximize your chances of success, both with the first project, but also in the long run, throughout the journey, by following what Eric you've mentioned, which is sort of my recipe for IoT success. And over there, I sort of listed eight areas. First one is building a partner ecosystem and learn to co-develop with them. The second one is attract and train new and existing talent. The third one is focus on solving real problems. The fourth one is prepare for a journey, not a one-time event. The fifth one is integrate technology solution with business processes. 6, start with low-hanging fruit. The 7th, make security everybody's top priority. And the last one, transform culture along with technology. They may sound obvious, but I can assure you, so many projects I've seen across the years that have not followed one or more of these ingredients, and they failed. So in a nutshell, if you do these things, you are maximizing your chances of short-term and long-term success.
I want to get into a bit on how you walk partners, walk people that you're working with through this journey. But before we get into some practical examples, you call it the IoT journey. A lot of other people around IoT, they use this language of this is a journey, right? This is a long-term transformation. You don't hear so much the same language with cloud. You're going to the cloud, or even with big data or something, which is, let's say, also there's a lot of hype or a lot of expectation around it. Why is the set of IoT technologies different in terms of the impact that they may have on organizations?
I think for me, it's probably less. So technology is one aspect of it. But if you think about, maybe stepping back a little bit, when you think about sort of internet, the buying centers and the people who have been adopting internet technologies, including cloud, have been primarily IT organizations, service providers, and obviously us consumers. In many ways, and often in the technology sort of industries, in many ways, IoT is different because IoT technology actually is targeted primarily at the line of business buying center. So folks that run businesses, they run hospitals, oil fields, cities, they run stadiums, agriculture organizations, and others. And from that perspective, these folks actually care about business outcomes. They care about performance. They care about quality. They care about top and bottom line. And they look at the technology as a tool to help them transform their businesses rather than just focus on let's deploy the latest sort of technologies or solutions. So that's the first reason. The second one is, again, if you look at let's say 20 or 25 years ago when internet sort of went mainstream, a lot of these industries that I mentioned earlier were not the sort of massive adopters of internet technologies. So in some ways, they still have a lot of sort of business structures, for example, around vertical integration. They have a lot of sort of I would say backward approaches from the technology perspective in terms of proprietary systems. The workforce relationships are different as well. Quite often in some of these industries, you go into a job, you stay in the same job for 10, 20 years, the job doesn't change very much. So the reason I mention all of these is it's not just the technology. Technology is the catalyst for much broader transformations. And as a result, we don't talk about, like with cloud, let's adopt cloud and integrate it into existing infrastructure. You have to change a lot of things from the technology, from the business, from the culture, from the workforce relationship perspectives in order for you to be successful. And you can't just do it in one swoop. You have to look at this as a journey. So that was one of the main reasons why we talk about a journey, because you're changing so many parameters.
Okay, makes tons of sense. And this is perhaps one of the reasons that IoT has not been adopted as rapidly as the technology has advanced. So you see a lot of new technology that's coming to market that on the face of it appears quite mature enough, and it seems to make sense from a business model perspective. But often there are adoption barriers that are unrelated to the technology, related to do we have the competence to implement and to operate this technology? Do we have the competence in our procurement department to analyze and choose the best vendors or the best partners and so forth? How do you start a conversation with a company that's beginning this journey if there's multiple parameters that they're going to have to consider, and you're going to be talking to somebody that maybe they're in the C-suite and they actually do have control indirectly over these, maybe they're below and they actually don't have control over all the relevant parameters, but nonetheless they're an essential starting point.
Great question. And quite often the conversation starts with, let's see what your peers are doing. Let's go through 10, 20, 30 examples across the industries of how different organizations are using IoT to improve their operations or to start transforming their businesses. And usually and by the way, the fascinating conversations are not necessarily within the same industry, but actually sort of getting ideas from examples in different industries. And then once you've sort of settled on okay, I think I'm going to start with, let's say, remote operations kind of a project. Then there are some little best practices. One of them is sort of have a great big vision and a big architecture, but start small. again, because of number of complexities, but also because you are starting on a change management sort of journey. And from that perspective, you will have naysayers. You will have people that will try to stop you. You will have a lot of silos you have to bridge. So sort of start with a small project, get the success, clearly articulate the ROI, and then ask for permission to do more challenging projects and more transformative as well. You mentioned C-suite. It's so important to actually have a C-suite support. Again, for the same reasons. You are dealing often with the mission critical environments and you're transforming them. So there probably will be mistakes. There will be challenges there. Make sure that you have a C-suite support and people that stand behind you, and then build a virtual team and establish partner ecosystem. So these are usually the sort of the areas that I would have a conversation with how to get started. And then once you've built this virtual team, build a ecosystem, get the first project, get the first success under your belt, and then you will be off to a journey.
Is there a case that you could kind of walk us through, somebody that you've worked with, and we can anonymize the name of the organization if necessary, but I think it's useful to have kind of a concrete example of a company where they started, what challenges they faced, and then how they walked around this.
If we have time, I can actually walk you through one example of each of these 4 use cases that I've mentioned. But I can start with one which is around connected operations. So HarleyDavidson, it's an iconic brand, obviously, of a manufacturer, and the whole value proposition is based on sort of a custom, right? Each of the buyers and drivers want to have sort of a special breed and special configuration of a custom bike. But before IoT, it used to take Harley up to a year and a half, up to 18 months from the time you would want to place an order for a new configuration to when they actually deliver the product. And the reason for it is that they actually have been sort of operating what I kind of jokingly call an archipelago of data islands. Even on the plant floor, they had different stations that were not connected, the data was not flowing. So as a result, the process were very sort of sequential and very manual. And the same goes for the rest of the sort of a value chain from ordering all the way to delivery. So in this case, a couple of folks from different walks of life in one of the plants in the US got together, and there was an unusual bunch. So there were folks from operational technology and IT and logistics and finance. They got together in one room and said, okay, let's fix it. Let's improve our operations. And they started by basically connecting all of the devices and processes within this one plant on one network, putting the automation and optimization analytics software on top. And then they sort of started expanding beyond that plant. So the long story short, when the data started flowing and they were able to start optimizing their processes, they were able to reduce the time for a new configuration to get introduced from, again, as long as 18 months to as little as 2 weeks. In the process, they were able to reduce the time to troubleshoot problems on the manufacturing floor from days and weeks to minutes. And probably equally significantly, they improved the bottom line by 2 to 3%. So that's one example.
And you said this was not so much started from, let's say, board or C-suite, but you said this was a group of operational leaders that got together to brainstorm how to solve this?
Correct. So there was very much an example of bottoms-up sort of approach. But I can give you maybe another example. In this case, was predictive analytics. So maybe again in a sort of manufacturing industry. So in this case, General Motors, they use around 30,000 robots, mostly from a company called Fanuc, a Japanese robot manufacturer. And typically, how the robots are installed on the manufacturing floor is that the Fanuc will come in, they configure the robots, and they sort of say, okay, and then call us if you need help, right? But GM and Fanuc and a couple of other companies thought, okay, what if we start connecting these robots? Then we can start getting real-time data, and we can start looking at configuration and trade-offs between use of material and how we use the robots. And they did that. They actually connected roughly half of the robots so far. And as a result of being able to analyze the data, General Motors actually reported that they were able to anticipate and actually reduce the number of stoppages of the production lines by around 100. And on average, at the system-wide basis, each of the line stoppages cost the company $2 million. So if you can do obviously easy math, GM was able to save $200 million by implementing the zero-year downtime solution for Fanuc. So this was sort of a top-down instead of a bottom-up approach.
Maybe just a little bit of a detour on this question, but I'm sure Fanuc, the producer of these robotics, also has interest in that data because that can be fed back into their production and their R&D and so forth. How have you seen, I think this is a very common question right now. There's multiple people who can find use in data, but once you give data away, it's very hard to track how it's actually used, and there's proprietary aspects to it. How have you seen this managed, so that you can maximize value and minimize risk, so to speak?
Yeah, and I think that there are a lot of cliche statements about data these days, right? And but I think that approaching data strategically is sort of the first aspect of it. And at the end of the day, more and more companies think of themselves as data companies versus a robot or a car manufacturers, right? Or even oil and gas companies. So thinking of user data judiciously, and to your point, sort of controlling the use and access is key. What I've seen is that, again, sort of the first one is sort of making sure that data is properly collected and stored. There are use cases that like, for example, oil companies right now analyze some of their seismic data from 30 years ago because now they have more modern ways of extracting oil. But also a lot of data is sort of data in motion. It's a streaming data, and how do you actually get insights from the data before the data is basically becomes too old and sort of loses value. But then, to your point also, there's a question of how you get access to the data to the vendors. Like, for example, Cisco, we deploy our routers and switches throughout our customers in environments. And many of our customers give us access to the data from routers and switches, not necessarily the payload, but the data that allows us to help troubleshoot and help anticipate problems with the network before they occur. So from the serviceability and from the management perspective. There are also aspects of data need to be considered from the privacy and security perspective, right? That and not only how you clearly communicate sort of what data, what you will be doing with the data and how your data is used, but also sort of making sure that the best practices are being followed. So great question and multifaceted question.
And you said there were two other use cases that you had in mind?
Sure. Probably the most popular use case that I've seen is remote operations or remote asset management. Lots of great examples here because you actually don't have to come up with a sort of a system-wide solution. In this case, you can have a surgical solution to solve a particular problem. If you don't mind, I can give you a completely different example from outside of the industrial world. So in this case, it's a 150-store ice cream chain in central India. And the problem they had was that they had power outages over there, and they installed generators in the stores. And sometimes there's a power outage at night, or managers don't turn the generators on, and as a result, the company was losing money because the ice cream was melting. But more importantly, they were creating a health hazard by freezing and refreezing ice cream. So in this case, a very simple solution. They worked with one of the local startups who dropped sort of self-contained temperature sensors in each of these fridges, connected them to the networks, and then connected them to the sort of a communication system. So now as temperature starts to go up, the employees and managers are getting messages through loudspeakers and SMSs and phone calls. Hey, do something. Maybe you need to close the door, or you need to turn the generator on. If the temperature continues to go up, these messages will get escalated all the way to the CEO. Again, a very, very simple solution. But what I loved about it is it sort of underscores the point of being hyper-local, because you actually need to think about the environment you're in, what problems you're trying to solve, versus, let's say, plopping a solution developed in Silicon Valley and dropping it in India and hope it works. And the ROI was also very powerful. This company actually saw 500% return on investment in the first year of operation of this system. And the last sort of set of most common use cases that I've seen is around preventive maintenance. And we see the preventive maintenance solutions in manufacturing, in the utilities, in agriculture. But the example I wanted to give you is from a mining industry. So I don't know if you've ever been to the open pit mine, but it's sort of a formidable site. You're basically looking at a hole in earth, sort of 2 miles across, 1 mile deep. And there are these little specks going around the edges. And these specks are these huge hauling trucks that basically have tires taller than a human being. And they basically carry iron ore or other minerals to the station and to the ports. And every time one of these vehicles breaks down, it costs the company on average $2 million of lost revenues per day. And by the way, the only way to pull out this vehicle is to use another of these huge hauling vehicles, which basically doubles the cost. So, and it may take days or weeks to figure out what the problem is, how to order parts, get the parts, and fix the problem. So what the companies did, they installed a bunch of sensors around these vehicles, started collecting data, feeding the data into the machine learning systems, and then basically providing predictions. Initially, these systems, when I got involved, were providing roughly 80% of sort of accuracy 3 months in advance, meaning 80% of problems were sort of predicted up to 3 months in advance. But as the ML system started to learn more, in some cases we can get to high 90% of challenges, meaning these vehicles will always get fixed before they break down, and very rarely they actually break down.
Let's go back to the third one, because I think this is a really interesting point, that a lot of the companies that are driving the economy are small, relatively unsophisticated companies from an IT perspective. And if they're faced with doing a GM, let's say a GM style, kind of top-down implementation, it seems extremely daunting, right? In these spot solutions, the one that you mentioned, excellent example of the mentality of let's do something simple to implement, high ROI, solving a very known problem, and then you hopefully generate some data, and that data might then be used to ideate and identify additional problems that can be solved, and you can build on that as a foundation. I had a question. I was in a podcast yesterday, but as the interviewer, and somebody asked, how can smart cities connect everything? Or that was the gist, or what is the strategy? And this is a problem in mentality of why do you want to connect everything? Why not identify what are your long-term problems as a city, and then say, has technology evolved in the past 3 years that now allows us to address this problem in a new way, and let's solve that problem? I'm interested in your perspective on this. How do corporations make the decision between when is the right time to think big and implement a corporate-wide solution, and when's the right time to think fast and implement a spot solution that solves a specific known problem?
Yeah, it's a great question. And going back to the smart cities, it's sort of funny because I work for Cisco, and so people, we basically build networks. But I basically tell people, stop talking about how many billions of devices we connect. It's not relevant. What's relevant is what business problems we solve. We're not connecting things just for the sake of connecting them. We connect them because they become basically they allow the data to get generated and connected from the devices, and we can analyze this data and turn them into solutions. So in this case, if you look at smart cities as an example, we've talked about smart cities for ages, but what has been a challenge for smart cities is basically coming up with the use cases that were actually relevant to the cities. And cities are complex from the ownership and sort of the right-of-ways perspective and so forth. And in North America and in Western Europe, we basically focus on 3 sets of use cases. It was either parking, second or third revenue, most important revenue sort of streams for the city, lighting, because one of the biggest expenses for the city, or trash bins or trash pickup. And we can get into these use cases, but each of those basically had a clear return on investment. And once you deployed a citywide infrastructure and a network for one of them, adding an additional use case was relatively easy. If you think about sort of again, this journey with the enterprises is, I would typically argue that for your first project, you should actually start with something very sort of focused, like this ice cream example, right? Because again, you're trying to minimize the vectors of sort of variability here. But at the same time, we've also seen a lot of examples of companies, for example, coming up with an automation system in one factory and a different automation system in a different factory. And now that when they actually want to build a system across the factories, they actually have to redo things. So once you've sort of started on your journey, you have a team, you have the established process, you should be able to tackle sort of the company-wide projects and then build the comprehensive architectures and so forth. So to summarize, I think when you pick sort of a very surgical standalone projects, make sure that they don't require for you to basically go back and redo these projects 2 or 3 years later. So pick the ones that you can then integrate into a broader sort of architectures and ecosystem.
I was interviewing a gentleman from PTC ThingWorks a few months ago, and he made the point. He advises, people in this space to let's say think big but smart small, meaning think first around what system might hypothetically be useful, and then you can start to address issues like standardization of automation system across factories and so forth, and then just start one. But at least when you start that first small project, you have in mind kind of the larger scope, and you can hopefully have some foresight into this kind of duplication challenge and so forth. Competitive disruption. This is one of the topics that you bring up in your book. We've been talking a lot so far about solving problems. Often these, the problems we've been really focusing on so far are often cost-based. And we've seen now some significant examples of disruption, a bit more in the consumer space, the Ubers. What do you see in the industrial space in terms of either today or in the, let's say, the 5-year time horizon, in terms of the opportunity for competitive disruption of revenue models due to IoT deployments? Yeah,
great question. And we've already seen a lot of disruptions happening today. So let me tell you sort of what I see today and sort of how we see sort of these things project into the next 5 years. But what I see from the disruption perspective is, first of all, the disruptions of sort of established market structures. So if you think about a lot of the industrial world, like for example, automation, industrial automation, traditionally these types of markets, and industrial automation is roughly $200 billion market, have operated as sort of one company developing the entire solution. So if you wanted to set up a new factory or build a new oil rig or set up a new train station, you would go to one vertically integrated conglomerate, and they will develop the entire solution from A to Z using often proprietary or semi-proprietary technologies. But with IoT and sort of an accelerated cycle of technology innovation, we're now seeing customers increasingly asking the question is like, why should I be paying a premium for a custom solution based on yesterday's technology? And instead, these customers are inviting specialists, whether they are horizontal specialists like Cisco or Oracle or Intel or SAP or others, vertical specialists, and sort of geographic specialists to work together in developing best-in-class solutions based on open systems, open standards, open architectures, and in some way are also future-proofed as well. So that's one big change. The other big change I've seen is sort of a balance of power. We traditionally have seen of customers buying technologies and solutions from the vendors. But increasingly, what we see is customers actually don't want to just be buyers. They want to co-develop these solutions with you, which actually makes sense, right? The customer actually knows what problems they have and their environments. And technology providers also are sort of experts in their technologies. So by doing things together, by co-innovating, co-developing together, what I call a co-economy, we're getting the best of both worlds. And then there's a business model disruption. A couple of years ago, we did a study. We reached out to some of our leading IoT customers, and we asked them about the transition from the product to service-oriented business model. And roughly 86% of them actually said that they were moving towards a service-oriented business model. Why? Because now they can. They have all the data coming from their operations, and they can make an intelligent decision that instead of, let's say, building a new plant, new assembly line, they can just buy the capacity that they need and basically bring the savings down into the bottom line. So if you think about that's sort of what's happening today, but what I see happening in the future, one is we're already seeing sort of merger of technology industry and the transportation industries. But basically every industry is becoming a technology industry, and we see some interesting correlation between, let's say, retail and manufacturing. So that's one trend. The second trend is new value propositions. When you think about Harley-Davidson example, they are a custom bike manufacturer, but increasingly what we're seeing is sort of the benefits of mass customization, mass personalization, and the cost of these actually being almost the same as sort of your Model T approach to products. And we see new industries being created, a combination of IoT and AI and blockchain and fog computing, creating industry of enterprise drones, for example. And of course, there's the migration to new business models. So it's sort of funny because as much as I'm sort of invested in the IoT success, I actually hope that 5 or maybe 7 years from now, we actually don't talk about IoT anymore. Like with e-commerce 15, 20 years ago, like nobody talks about e-commerce anymore. It's just part of everything that we do. I actually hope that with every company, large and small, in every industry, sort of starts adopting IoT as part of their operation. And in 5 years, when you and I are having this conversation, we just say, remember this discussion about IoT? Now it's just part of a process, and we take it for granted.
I agree, although we have IoT in our name, so we might have to rebrand at that point.
I'm sure there will be a new term that we will all can rally around.
Last question. You've participated in many deployments. It sounds like a good number of them have been successful, although I think Cisco actually released a report earlier in the year that estimated 75% of IoT deployments had failed to meet their objectives.
Yet, yes.
Yet, exactly, yeah. So what advice would you give an organization that's starting this in terms of taking their first steps wisely in order to minimize the risk of failure?
I sort of mentioned this at the beginning of a conversation, but I think it's so important that, first of all, get started. Second, don't be a hero. Don't reinvent the wheel. We've discussed these 4 different use cases that are across the industries, most common use cases that your peers are already using. So connected operations, remote operations, predictive analytics, preventive maintenance. Pick one of them and get going. Thirdly, sort of dream big but start small. Get support from your CXO and build the ecosystem and build a team. Fourthly, learn from your peers' mistakes, because like with any new effort, there will be mistakes, and most likely some of your peers have already made these mistakes. And lastly, we started with the discussion around the recipe for IoT success. Use this recipe because it's based on sort of sweat of many deployments and best practices. And if you do that, you will maximize your chances of success. And maybe the last point is this type of journey is a team sport. It's not for loners. It's not for sort of lone innovators in a garage, right? So approach it comprehensively. Bring your company, your industry, your peers with you on this journey. And that if you do all of these things, I'm pretty sure your first project will be successful. And then you will not look in a rear mirror. You will just charge ahead.
Thanks so much for taking the time to speak with us, Maciej.
Thank you so much, Eric. I really enjoyed the conversations. Great question.
How can people learn more about the work that you're doing at Cisco, learn about your book, reach out to you?
I would suggest, you can obviously read the book. It's on at all the major retailers. I also have a website, maciejkranz.com, and also the LinkedIn group. So we actually have a lot of discussion on the Building the Internet of Things LinkedIn group about the best practices and exactly the topics that we discussed here as well. So go read the book, join us at the LinkedIn group, and ask for advice and help. We're here to help you be successful.
Thanks again. Have a great evening.
Thank you so much, Eric.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@IoT1.com.
Thank you for joining us for another episode of the Ventures in Industrial IoT series. You can learn how GE Ventures goes beyond funding to support their partners in technology development and commercialization at www.geventures.com.